Chapter 2, 2.1. First, we're going to be doing a lot with identities. So remember this handy dandy unit circle? This right here, fundamental trig identities, is what I will often be referring to. So when I talk about trig identities, these are things that once we use, and you should already know these by now, the reciprocals, but using these, we're going to be using this on a constant basis that you're going to start just tending to memorize them. So first, find the values of all 6 trig functions. Well, one thing I see is that the secant is negative and tangent's positive, so I know it's not in quadrant 1. Secant is the reciprocal to cosine, so if cosine's negative, and I'm looking at this, and tangent's positive, so all sad turtles, it would be in this quadrant right here. So in this quadrant right here, if this were my angle, and cosine is hypotenuse, right? Secant is hypotenuse, so that would be my 3 over my adjacent. If you wanted to, you could have rewritten that so it was cosine. But now I have my 2 side lengths, and I can figure out my third side length by doing a squared plus b squared, which we don't know, is equal to c squared. So b will be equal to the square root of 9 minus 4, which is 5. And because this is in the third quadrant, that's going to be negative. So if I wrote down my 6 trig functions, you get your opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then the reciprocals of all of those. So example 2 is simplifying. Now we're going to start getting into more of our fundamental trigonometry identities. The first thing I see is that there's a sign in both of these. So I can factor out a sine of x, leaving me with a cosine squared x minus 1, because that did not disappear. Again, if you look at your trig identities right now, we do have this trig identity with sine and cosine. So if I wanted to get the cosine and 1 on the same side, I could subtract that over. But notice how it's not the exact same as what we have. So actually, I'm going to go back and I'm going to take out a negative sign. So if I take out the negative sign, this cosine is negative and this 1 is positive. Why did I want to do that? Because right here, if I want to rewrite this, if I subtract the cosine squared, now I know that sine squared would be equal to 1, a positive 1, minus cosine squared. So now I can take this whole parentheses, and instead of writing this all over again, I can say that that's equal to sine squared x. And now I can multiply those two together, and I'm going to have a negative sine cubed x. And that right there would be my simplified form. So now we're going to factor. This is where if you are factoring from earlier years, from in college algebra or years before, it's the same type of thing. If I had this to factor, it's the same thing over here. So in this case, if I'm just asking you to factor, because there's no middle term, I can split this up because of the fact that there's no middle term and this is a perfect square as secant theta plus 1 and secant theta minus 1. Because right now they multiply to get that secant squared. These multiply to get my negative 1. If I do my outside, that's a negative secant. Inside is a positive secant. So now I am looking at my tangent. If you wanted to rewrite this, it's the same type of thing as if you had this. So if you were to factor that, I'm not going to do that each time, but if you wanted to visually see how these are the same, it would look something like that. So I have my 2 parentheses, so I have to think, how can I multiply these together so that when I multiply, I get this 4 tangent squared and negative 3, but when they add together, they get a positive 1. So I see that I can have 4 tan theta, 1 tan theta. You don't have to write that 1 there, but now these multiply to get that 4 tan squared theta. Now, when I'm doing this, I know that 4 and 3 have a difference of 1, so I'm going to put my 3 over here and my 1 here, because these have to multiply to get the 3. So I want to multiply, and when I add the 2 together, I want to make sure I have a positive 1 in the middle. So this would be a negative, because this would multiply to get a negative 3, and this would be a positive, because this would multiply to get a positive 4, and then when I add those together, you should get positive 1. When you do this, you can always do multiply it out first outside and inside last to check your work. So if I ask you to factor and there's not the same, well, again, let's go back to our train identities, especially a Pythagorean. So I have a cosecant squared. Do I have a cosecant? Oh, I do. Cosecant squared right there. So I'm going to replace cosecant squared with this 1 plus cotangent squared. And that might be beneficial to us. 1 plus cotangent x, so that is cosecant squared, minus this cotangent x minus 3. And now I can combine like terms because there's no multiplying over here. So this would be equal to cotangent squared x minus cotangent x, or minus 2, because that negative 3 plus 1 gives you a minus 2. And again, you could rewrite this so it looks like this, and sometimes it's easy for people to visually see it, but I will not be doing that each time. So I'm looking at what multiplies to get negative 2 and adds together to get a negative 1. So I have cotangent x, and then I would have a minus 2 and a positive 1, because I multiply to get that negative 2 and add together to get that negative 1. So example 5, we'll be getting into more of this in the next section, but one thing, when I ask you to simplify, it would be always beneficial if you can, if you already have sine and cosine, change anything else there to sine, cotangent, cosine and sine. So right here, we have this cotangent. We can change that to cosine over sine. So right now I'm going to have my sine t plus, instead of writing cotangent, I'm going to write my cosine over sine, cosine t over sine t, times cosine t, just like that. So what I actually have here is sine t plus cosine squared t over sine t. Now, whenever you have one fraction and the other one is not a fraction, you want to come up with common denominator. So I'm going to multiply this by sine over sine. The reason I'm doing that is because I want to combine these two fractions. So I'm going to move up here. This becomes sine times sine, because this is like over 1. Sine times sine is sine squared t over sine t, plus our cosine squared t over sine t. So now, because they have the same denominator, we have sine squared t plus cosine squared t over sine t. And again, if you look right now at your Pythagorean identities, we know that sine squared plus cosine squared is equal to 1. So now this whole top part can be replaced with just 1 over sine t. And because we are so good at the 6 trig functions, 1 over sine is the same thing as cosecant t. And that would be my final answer. So just kind of like how this is here. If we have two separate fractions, we want to make sure to set up one equation. So we want to combine those two fractions. So finding our common denominator. Our common denominator here would be sine theta 1 plus cosine theta plus sine theta. And depending on how comfortable you are, you might not be writing it out in two, but just so I can visually show you what's going on here. So if this is my common denominator, I already have the 1 plus cosine. I have to multiply the top and the bottom by sine. So now I have that sine 1 plus cosine on bottom. On top, I'm going to have this sine squared theta. Over here, I'm going to have to multiply, because I already have the sine 1 plus cosine theta on top and bottom, 1 plus cosine theta. So now when I distribute this, this becomes cosine theta plus cosine squared theta. So if I combine those together, this is what I have. Now, just like how we talked about right up here, when you have sine and cosine together, that can be replaced with 1. So I can replace this whole thing right here in that parentheses with 1. So I'm going to have 1 plus cosine theta over our denominator, which is sine theta 1 plus cosine theta. Do you see what just happened there? This can be grouped together now. That is just one number, and that's the exact same number. Because of this parentheses, that whole shebang, these two can cancel each other out, which is 1 over sine theta. Oh my gosh. And again, those 6 trig functions, we know that this is cosecant theta. What if I ask you a question like this? Well, if I ask a question like this, I want to get rid of that denominator. So this is where we have to know the conjugate. So we want to multiply the top and bottom by the conjugate, which is 1 over sine x, to see what that gets us. So if I multiply the top, I would have 1 times 1 times sine x. So this is what I get. On bottom, I'd have 1, and then I would have minus sine x plus sine x. And I would have a minus sine squared x, which these two cancel out with your conjugate. So I have 1 minus sine x over 1 minus sine squared x. And again, that trig identity that we have right here, if I have 1 take away sine, that's going to be equal to our cosine squared. So I have 1 minus sine x. However, if you remember, the whole thing is that I don't want this to be a fraction. But now at least I got rid of the adding and subtracting on bottom, so I can split up this fraction as 1 over cosine squared x minus sine x over cosine squared x. Maybe you see where I'm going with this, but 1 over cosine would give me a secant squared x. I'm going to still write this as our sine x over cosine x times 1 over cosine. So I split up that cosine squared. That's what I did there. So then I would have a secant squared x, and if I don't want any fractions, I could say minus sine over cosine is going to give me a tangent x, and 1 over cosine is, again, secant x. Technically, you could take out a secant, but I don't want to. I got rid of that fraction. I'm golden. And last but not least, substitute this whole thing in for x, knowing that your angle is in between 0 to pi over 2, and see what the trig function for theta would be. Well, first, I'm going to plug that in for x. So 4 plus, in parentheses, I have this 2 tan theta, that whole thing squared. Because of this multiplication, and only because of that multiplication, we can distribute this to the tan and the 2. So now what I have going here is 4 plus, this becomes 2 squared, which is 4, and then tan squared theta. Well, I see these 4's here, so I'm going to take out a 4. So I have a 4, and then I'll be left with if I took a 4 there, I'd be left with a 1 plus tan squared theta. And again, I'm trying to force those trig identities. And we have a trig identity that would give us 4 times 1 plus tan squared is going to give me secant squared theta. And now, because of this multiplication, I could rewrite this as the square root of 4 times the square root of secant squared. Not everyone has to do that step, but I just want to make sure that you see, because of the multiplication, not with addition, but with multiplication, we can rewrite this as 2 secant theta as my final answer. There you have it. Bing, bada, boom. Have a great, have a wonderful day.